All right, let's look at these lesson 1.5 notes. These are going to be technically the notes from day 4 when you look it up on the daily log or on the calendar. And ideally, this is a lesson that we would have done in class, but we didn't get to do that. So we're just going to kind of do it online. And so what I would ask you to do is kind of take a minute to look at the examples below. And what we're trying to notice is any consistent observations that you see that connect the inequality notation. Let me get this marker up. The inequality notation to the number line graph to the interval notation. And what we are doing in this lesson is really learning how to use interval notation. That, for the most of you, should probably be everything. Most of the time when you've seen things that are not equal, we've used the inequality symbols. And so something to keep in mind is what those symbols are. So in this first one right here, this says x is greater than or equal to -3. So I'm going to go ahead in the notes here and write that in. This is greater than or equal. Greater than or equal. So that means that x can be any number starting at -3 or bigger. All right. So when we look at the number line graph, we can see that's happening. So here we have a number line, and on that number line are all the integers, right? And we assume it keeps going in the negative direction and it keeps going in the positive direction. And we are going to highlight or mark out or shade all the values that x is allowed to equal. So we said x can be anything that is -3 or bigger. And I like highlighting it just so I can see it really well. So this is how we mark an inequality on the number line graph. Well, in mathematics, a lot of times we use interval notation to talk about the exact same thing. So if you look over here, here's the interval notation that matches up with this inequality in the number line graph. And I just want you to notice what's happening here. So we've got a bracket, and then we've got a -3, and then we have comma, infinity, and then an open parentheses. So we've got brackets and we've got parentheses. So one thing I want to make a note of is that in this interval notation, clearly the first number is where the interval begins, and the second number is where it ends, and it's separated with a comma. So we've got the beginning and then the end. All right, so instead of doing that with arrows, we can just make a note that in the interval, you do the beginning. Let me start that. Whoops. You have the beginning number and the ending number, okay? And then you're going to have it surrounded by either brackets or parentheses, and we have to decide when to use a bracket and when to use a parenthesis, okay? All right, this one right here says that x is less than. So when the symbol is shaped like that, this is less than. So x has to be numbers that are less than 1. But it can't include 1. There's no little equal thing here. So x can't be equal to 1. It has to be less than 1. So the way we show that on the number line graph is we put an open dot on 1 to say it can't actually equal 1, but it's going to get really, really, really close. So it can be all of these numbers that are less than 1, and it can get right up to as close as possible to 1. So it can be 0.999999999, I mean, as close as we can get. And so the best way for us to show that is to do it with an open dot. Open dot means it can't actually equal it. And then we shade everything to the left. So notice over here now, on our interval notation, if we look at this number line, we look at and we say, well, what's the lowest, what's the starting number for x? Well, according to this x just keeps going to the left forever. So it actually starts out at -infinity. There's no left end starting point, but it has a right ending point at 1. And this time we used parentheses for both. All right. In the third one, x is in between two numbers. So -3 is less than or equal to x, which is less than 5. So that means that x is between -3 and 5. We can see that here. and x can be equal to negative 3, so we have the closed dot there, right? But it can't be equal to 5, so we have an open dot here. And we're going to do this here, open dot, because it can't equal 1. And on that previous example, closed dot, because it can equal negative 3, all right? So the interval notation on this, notice, it starts, x starts at values of negative 3 and goes to 5. We have a bracket on the negative 3 and a parentheses on the 5. So hopefully what you're starting to see is that when it's a closed dot, or when x can be equal to that, we use a bracket to say, hey, negative 3 is included. So we're going to start at negative 3 and include it, and we're going to do every number between negative 3 all the way up to 5, but we're not going to include 5. Like we can go to 4.999999999 forever and ever, but once we get to 5, 5 is not a value of x, okay? So x can take on every single value in between these, all the decimals, all the rational, irrational numbers, everything. All right, here's an or. In this case, on example E, x can be less than negative 3 or greater than 0 and not equal to either. So x can be any number smaller than negative 3 or bigger than 0. So on the number line, we have the open dot on negative 3, and then we've got everything below it. And we also have an open dot on the 0 and everything above it. So we actually have two separate intervals that x can be equal to. So when we write it as an interval, we do it like this. So x can start way down here at negative infinity, and it can go all the way up to negative 3, but not include negative 3. So we do parentheses. And we use parentheses on the infinity also because we can't ever actually get to that point. Then you have this U symbol, and then you have your second interval, 0 to infinity. Now that U symbol stands for union. And in math, that means or. So x can either be in this interval or it can be in this interval. It can't be in both because they don't overlap, okay? All right, so let's look at some connections down here. Let's talk about the things that are important. When we're doing interval notation, we need to use for a bracket symbol, right? For a closed end dot. Okay, all right, which means it's including that number. Can be equal to. Okay, so use brackets when it's a closed dot or when the inequality has an equal to with it. If it's not, if it can't equal it, then we use parentheses. Okay, for an open dot. Okay, we also use parentheses for infinity, for positive infinity and for negative infinity. Okay, and then the U symbol means or. Okay. So just something to keep in mind, brackets, that's a closed, what we call a closed interval. All right. If it's parentheses, it's open, and we use it for an open dot or negative infinity or positive infinity. Okay.